Hello everyone, welcome to this video. My name is Pem, and in this video we're going to continue where we left on FRIDA. So we are going especially to deal with the two main functions of FRIDA that we had talked before. We are not going to demonstrate the SSL pinning part, but we are going to demonstrate and practically show how to bypass the untruth mechanisms as well as hooking of functions. This is just a scratch on the surface for FRIDA. You're going to see how powerful this tool is and how important it can be in as far as dynamic analysis of Android application and even iOS applications is concerned. So we are going to use a very good Android application developed by WASP. I liked it because it's kind of it gives you an overview of how FRIDA can be utilized and how actually developers can overlook some of the things that that are very important in making Android applications secure. FRIDA can be able to bypass some of the functions, can even as long as those functions are not dependent on the application's functionality. Let's go to our browser, then you type WASP Uncrackables, search for it, choose the first one. This is the one that we are going to use, Uncrackable Level 1 APK. Just download it. I had downloaded mine before. Let's start Genymotion because we'll have to install this application. As I have told you in the previous video that dynamic analysis is about analyzing an application as it runs at runtime. Again, you know how to install Genymotion and the whole phone and all this. If you have not, you don't know, then watch the previous videos, then you'll be able to know how to do all these things. Let me uninstall so that I can show you how probably we brainstorm what happens. Next things we are going to do is installing this application on this phone. Okay, from our previous videos you should be aware of ADB, so it's just ADB install then Uncrackable Level 1 APK. It's going to appear somewhere here, so click enter. See, it's here. It's okay, success, and as you can see, it's here. Let's open this application in this phone. Okay, it's saying root detected. This is unacceptable. The app is now going to exit. Okay, and if we click OK, surely it exits. Okay, so how are you going to bypass that? Now, this is where static analysis comes in. You can be able to know which functions are responsible for this root detection. Okay, this is why dynamic analysis and static analysis go hand in hand. There are so many things that you understand by doing static analysis of an application. Let's go back and do some static analysis of this application. Okay, we want to know the function that is responsible for this message that it's being displayed when we open this app. Okay, so let's use JADX GUI, and then we analyze what happens with these. So I had already opened this. We have the source code. This is the Uncrackable Level 1 APK. You have the source code. Okay, WASP MSTG Uncrackable. Here it is, and we have SG Vantage Point. Okay, I guess this is the package name, but as I've told you before in static analysis, the first place to start with when you have decompiled an APK is the manifest file. Okay, so let's look for manifest file, which is normally located in resources. Okay, so this is the manifest file. Okay, we have package name, which is WASP MSTG Uncrackable 1. The next thing we are interested in is what is the main activity of this app. What is the first activity that is being called when this app opens? An activity, as I've told you, is the screen. Okay, it's like the screens, but each screen represents an activity. So this is the main activity. So let's open this main activity. Okay, so we have the main activity here. As you can see, there is an alert dialog. Okay, when this application is opened. Okay, under the same main activity, we have this protected method on create. Okay, on create, and it seems like it is checking three functions actually. If c.a method or c.b method or c.c method, then it is display root detected. Okay, it's like these two methods are the ones that are being checked first. If n of them becomes true or n of them goes through, then we get this root detected. Okay, we need to know whether the application is dependent on these methods for it to function. Okay, or is it that we can just bypass with these methods and then we can be able to do without them. So let's look into this Vantage and A class. Okay, C class especially .a.c class. Okay, so we have Dex classes here, but let's go here, SG. Then we have these then we have these functions. Okay, this is the SG Vantage first method, A, B, and C. Okay, public class C. It's like it's checking the parts of the system files of the Android phone. Okay, or Android device. So if there is a file that has a string su and it exists, it returns true. Otherwise, it should return false. The second method checks if there is test keys. If there is a string that contains test keys in the build tags. And the third method, it does some checks on the super user, whether there is a super user APKs, whether there is a demo that is running, or there is basically there is whether there is a super user that is running. And you know, when a device is rooted, automatically these are some of the things that exist. So those are the three methods that this application is going to depend on, and these are the checks that are going to be done. And you can see these are Boolean functions. Of course, you see it returns true or false. So that is pretty very simple. There is nothing more that this class does or these methods do. So we can bypass them and still the application will run. Okay, this is where now FRIDA comes into play. We are going to create JavaScripts and run using FRIDA. Okay, I had come across some of these anti-root bypass, JS, and the whole of this thing. A disclaimer, they are not mine. I just found them in the world, and if anyone knows the owner, then just reach out and I can give credit to them. So, and I put them in under my repo. This is bypass. So let's check, for example, the first JS that is used to disable the root detection. Okay, as you can note, we realize there is this class sg vantagepoint.ac. okay, .ac. Let's go back to this. This is sg vantage point, then under A and then under C. Okay, this is the C we are talking about, A and then C. Okay, so this is the class that has all these. This is the class that contains all these three methods. Okay, this is the class that we are going to use. So this class, which we have, it's being referenced the class, then .a, which is this method, then we use the implementation is the function, then it must return false. Same to B, same to C, let it return false, and then everything is complete, and that is it. That's the very simple script that we are going to use. Let's just copy this, copy these functions and put them in our folder. Just open a file and then anti-root. Okay, let's paste it here. Okay, save. Let's also copy the other one, create the other one for, let's just call it hook. Okay, then this bypass, copy it again, then paste the code here, save. So now we have the two files that we are going to use. Okay, now let's open a new tab here. Okay, the next thing we are going to do is start the FRIDA server. You remember we are going to use ADB to run that FRIDA server. Okay, let's run the FRIDA server. Okay, so it's running. Let's open another new tab again. Okay. Before we use FRIDA, let's find out the processes that are running, okay, so that we can be able to identify the identifier that we are going to use. Okay, it seems the application is not running. Did we not? Yeah, it's not running. Let's run it again. Yeah, there it is. Yeah, it's here. So we now get it. Perfect. This is the identifier that we are going to use. So let's type FRIDA dash capital U dash L, and then and JS and root JS. Then we're going to force it, and then let's copy this identifier and paste it here. Okay, and then we're going to use no pause. Okay, I think that is okay. I want you to look here. What will happen? You see, it's gone and it's come back. We no longer have the root. Actually, what FRIDA does, it becomes a middleman. It can be able to intercept a function just before it executes. Okay, next thing we want to see how really hooking of functions are being done. And so let's go back to the second part of this uncrackable challenge. Okay, there are two challenges of this on this uncrackable one. You see, we need to verify. There is a string that we need to verify here. Okay, we need to type something here and verify, and there is a function being called, okay, after we input any input on that text field. Okay, so we want to find out which function is responsible for this message. Okay, the best script that we are going to use here is the one that is going to detect the root and disable it, the anti-root, and disable it, and then it's going to hook this function and be able to give us the best string that we are supposed to input here, so that we can be able to successfully crack this challenge. I love this challenge because it relates to really what's happening outside here. This is not like a CTF like stuff. It's not like just for CTF purposes. That's one of the good things about these mobile CTFs. They actually resonate well. If you compare them with the normal CTFs in the wild, the normal desktop machines, Windows and so forth, the other OS, the one for mobile applications are actually relatable, and you can actually be able to understand what happens in real life, and you can apply this knowledge as well, because this is just a demonstration, but in real life it happens. I have come across one. Now, if you remember, this is the function that is used to perform root bypass, the one that we've just done. Okay, so let's go back to the code again and see which function is it that is responsible for this message. That's what we want to find out. Okay, so let's find out here. Let's go back to the code, and then of course the main activity. Let's go to the main activity. From the main activity again, because these applications seems to be having only one activity, okay, it is only one activity, I don't see another. It is from this method verify, okay, this is the method that is being called, okay. So it's like this object is being compared to another, okay, and if it is the same, and then we get this correct secret, and if it is not, then we try again. So let's see which method is this, okay. This is the method. So it seems this function, it takes a text from this text field and then it compares with whatever string that comes from this object here, okay, from the object that comes from this function, okay. So this is the function that we are going to hook. If you come to this code, we are using this class .a, okay. So there is a method a in AA, okay, there is a method a in AA. We have this method a and we have this method b, okay, in this class A. So there are two variables that are being called with. If you can see here, we have this first variable that we want to call it with, and we also have this one. So those are the two that we want to call this function with, and then we are going to print the value of those two variables, okay. We use the implementation of that class, then we call the function. We store the return value of this function in this variable that we've called raw function call, okay. Then we are going to convert the return values into string, an array of strings, okay, and then we are going to print that output. Simple as that. So let's do that. Let's go back to, let's close this one. So let's go back to our terminal. Now let's call it with hook now, okay. Now it's going to do the whole process because we've included that code, the anti-root code end. So let's type here and call that function. You can type whatever gibberish you want to type here. So you see it has printed for us something. So let's see whether this one is going to work, okay. That's not it again, try again. So let's type this one now. I want to believe, and see whether we are going, that is the correct, I want to believe, verify, and that is it, and we have successfully solved this challenge. The application is being forced to give us what we actually are supposed to input in this field. So that's how FRIDA is utilized in dynamic analysis, to hook functions and manipulate functions to do whatever we want those functions to do, vis-a-vis what the creators intended those functions to do. So that is it for now. Thank you. See you in the next video. Bye.